Edge designations, CFA Level 1, pre-reading, quantitative methods, Learning Module 2, organizing, visualizing, and describing data. This is the second learning module in the quant section in terms of the pre-reads, and we already covered the first one, which was interest rates, present value, and future value. That was learning module 1. We now continue onwards with learning module 2, organizing, visualizing, and describing data. And a large component of this particular learning module will deal with exactly that, how we organize and visualize data. We then move on into some of the more detail behind some of the quant sections, and we look specifically at the first two moments. If I just show you those over here, we'll be dealing predominantly with measures of central tendency and then measures of dispersion. Those are the first two moments within a distribution. Okay, of course we've still got skewness and kurtosis. Those aren't specifically handled here in the pre-read. Those will then be handled later on in the core readings. As per normal, guys, what we do is we show you the learning outcomes, okay, for learning module 2. There we go. Okay, quite extensive, okay, at least for a pre-read. It looks like quite a lot of information, but it's a lovely reading. It's a gentle reading. It really just discusses a lot about organizing the various data as well as its visualization. Let's get going straight away, and we hop into learning module number 2, and we compare and identify the various data types. Okay, first and foremost, we talk about numerical data. Everyone knows about numerical data, and if we had to give one word for numerical data, a good word for that would be quantitative data. Okay, in other words, values that can be measured or counted. Okay, now we move into two different types of numerical data, okay, discrete and continuous data. And I want to use an example that we used from learning module number 1, interest rates, okay, just to give you a bit of a sense of what we're talking about over here. Okay, so we start off over here, and let's say, for example, I've got time period 0, time period 12, let's say, for example, it's 12 months, it's a year, and then I've got different periods. I've got time period 3, time period 6, time period 9. Those are my various time periods, and I'm talking specifically here, guys, about interest rates and how often I compounded those rates. So in this particular example, what would you tell me? Well, this is obviously quarterly compounding. In other words, I compound 4 times a year. At time period 3, 3 months later, time period 6, 3 months later, time period 9, and again 3 months later at time period 12. This is what we would call, I'm just going to change my color over here, this we would call discrete data. Why discrete data? Discrete is at specific points in time. What do you notice about discrete? The outcomes can be counted. How many times am I compounding? 4 times. We can count it, nice and easy. Okay, when I move across then to continuous data, and again I want to still be speaking about interest rates. Okay, the values cannot be listed. And why can't they be listed if they are numerical stroke quantitative data? They can't be listed because they're too numerous. Okay, let's go back to my interest rate example over here. When I talk about interest rates, and they are compounded now, not quarterly, because that would be discrete data. They are compounded continuously. Well, now look how they compounded every single second. I don't stop compounding. Second. Now you say, what about all this compounding? Wow, isn't this fantastic? And guys, you can go back to learning module 1 and just learn a little bit more about that, continuous compounding. What do you notice, of course? Okay, yes, okay, it still is numerical data. Yes, it's still quantitative data, but what do we notice about it? We can't list them, they're too numerous. Okay, because the compounding happens, what, guys? Continuously. And if you remember going back to learning module 1, how do we solve for continuous issues or for continuous data? The only way to solve that is to make use of logarithms and exponents. Okay, and there we go. I'm not going to spend too much more time there. We continue onwards to the second major type of data, which is called categorical data. Categorical data is also known as qualitative data. In other words, it describes the quality or the characteristics of a group of observations. Okay, we break our categorical data down into two: nominal and ordinal. Okay, when I look here at nominal data, what do we notice about nominal data? Nominal data is exactly that. It's just nominal. It's got a number. Let's say, for example, I'm dealing with my class and I've got males and females, and I decide, okay, I'm going to call the females 1. That's nominal. I'm giving them a name. I'm calling them 1s, and I'm calling the males 2s. Now, what do you notice? It's purely nominal. It just gives them a name. Or is the fact that females were given a 1 and males were given a 2, does that make females better than the males because they got a 1 over a 2? It means nothing of the sort. Okay, of course not. And it's just purely nominal. It's just there to give it a name. For the same price, guys, I could have called the females 7s and the males 2. It makes no difference. It's a way of, so in terms of measurement, and look what we say over here, nominal data is the weakest level of measurement. Ordinal data, here order does make a difference. Look at the words order. The values represent an ordering. We're going highest to lowest. Okay, but again, even within ordinal, I've just got to mention this, guys, okay, that yes, ordinal does give an order. Let's say, for example, 2 of us had a race. The guy that came first was you, and I came second. Now, what would you conclude from that in terms of the race? You would conclude that you are faster than me. Why? Because you came first, and we are dealing in orders over here. Everybody comfortable? Okay. What it doesn't tell me, what this doesn't tell me is how big of a difference there is between you and me. Now, let's say, for example, it was a marathon, okay, and you run the marathon in 2 hours and 10 minutes. That's quick, by the way, okay. Me, I ran the marathon in 4 hours, 25 minutes. So all that this tells me, ordinal data will tell me, okay, that you are quicker than me. You run marathons quicker than I do. But doesn't tell you just how great the difference is, which is actually massive. You can see you run the marathon in over 2 hours quicker than I do. Okay, that's one of the weakest. That's one of the weak areas then of ordinal data. Okay, and obviously there's some examples for you there, guys. Just a word, a note in terms of the edge notes that we provide for you over here. Okay. There are sometimes my students say, oh, you put in too many examples, and I say, I know, but I'm not sorry. Okay, it's always good to have a bit of extra examples to go through if you need be, but obviously I'm not going to go through each and every single one with you, but they are in your notes, and of course when you go through them yourselves, please look at the various examples. Okay, we look at 3 different kinds of data. Cross-sectional data. It's taken at a single point in time. Okay, time series. Okay, it's data collected over a period of time, daily, weekly, monthly. Okay, and there we go. Okay, we move down over here to panel data. What's panel data? Panel data is a mix of a time series, in other words, data over a period of time, and cross-sectional at a specific point in time. Often we see these things in like a kind of like a data table or a matrix format where we've got specific data but over a specific time period. Okay, and hence the term panel. It looks like a little bit of a panel. Okay, it's organized in something almost a little bit like an Excel type table or a data table stroke matrix format. Okay, over our page over here, and the last little bit of data. Okay, structured versus unstructured data. Structured data is nice, is lovely data. Everybody wants their data, of course, to be structured. Okay, and it's easy to enter, to store, to query the data, etc., etc. Nice, neat, and cleaned up data. It's names of people, perhaps addresses, cell phone numbers, all good things like that. Unstructured data has got no conventional organized form. Okay, things like news. Okay, so you can have a whole news report, and that is what we would call, yes, it's data. Okay, the news report is data, but it's completely unstructured. Okay, it can be classified into one of the following groups: produced by individuals, generated via business process, and I'll talk about this last one, generated by sensors. Okay, you could well have the sensor at the entrance to a business, okay, picking up people as they come in and out of the business. Now, but that's just completely unstructured data until such time as you take that data and now you want to clean it up and say, well, how many people came into the business today that had blue eyes? How many people came into the business today that were male, that were female, that were whatever? And then we can take unstructured data, yes, in its raw format and structure it into something more useful. Okay. We move down a little over here. Describe how data are organized for quantitative analysis. Generally speaking, raw data is often not suitable for use. Okay, and obviously in order to make it a bit more useful, it needs to be cleaned. Raw data can be organized into two formats: one-dimensional arrays and two-dimensional rectangular arrays. Okay, some people call them arrays or arrays, call them whatever you like, it's all good. Okay, on the one-dimensional side, it really is a simple way of representing a collection of data. Okay, and it's one-dimensional. So, for example, over here we show the opening price of a share for 15 trading days. It's only one dimension of the particular stock, is its opening price. Two-dimensional is we're showing two different dimensions, but remember, the minute we start to go for two different dimensions, then we need columns and rows to contain all the variables for the various observations. Okay, we move over here to interpret frequency and related distributions. First of all, what is a frequency distribution, guys? It's important, just before we get going over here, if I had to say to you, I'm going to present to you my sales for the last 3 months. My sales were $100, $300, and $700 for the last 3 months. Okay, what would you call that? Okay, all you can say, well, it's 3 months worth of data. That 3 months of data is called a distribution. And it's important to notice that, because don't get overly, and one of the things with quants, a lot of people look at quants and they become completely overawed by it, and frequency distributions. And a distribution is just a collection of data over a period. That is my distribution. Now, if you wanted to give it more, a little bit more meaning, you could say this is my sales distribution over the last 3 months. Everybody comfortable, but it's just a distribution. A frequency distribution is really just taking that same distribution of whatever it is, okay, of whatever it is, and now we're going to put it into a nice frequency. Frequency is just a different way to summarize it and to present it. Let's go to our page over here, have a look. Okay, and we see, by way of example, guys, a group of 20 shares on the stock exchange are to be analyzed with respect to their dividend yields. Okay, so we look at the following 20 shares, and there they are. Look at the dividend yields on them. Wow. What does that mean to anybody? Very little, and it's quite difficult to analyze it. It's not in any kind of an order. It's not in any kind of a shape or form. It's just 20 shares with their dividend yields. Okay. When we come now to analyze what we call a frequency distribution, what we want to do is we want to take this particular data and we want to organize it into something that's a bit more easier, meaningful, and visual that we can make use of. Okay. So first and foremost, we want to choose suitable group size. I want to break these 20 down into groups that are more suitable. Okay. Rule number 1, not too many and not too few groups. When I make my groups, which we're going to be calling, guys, class intervals, I want all the class intervals to be the same width. Okay, and every one of these values of the 20 shares and their div yields can fit into only one interval. Okay, when we look at the data over here, guys, one thing that we do notice is that what? The values range from 1.4 to 9.4. There's my 1.4 on the low end, and there's my 9.4 on the high end. Okay. Now, and this is purely every time one would need to do such a thing like this in real life, you would have to somehow go through this process. Okay, well, the lower level is 1.4, top level is 9.4. It's okay, and look what we conclude here. A class width of 2 units should do the trick. How did I come to that? Purely experience and purely, but you'll see what we do when we come over here. Okay, so look what I do. So remember what we said, guys? We are going to use a class width of 2 units. Okay, so what is a class width of 2 units? Okay, we go 0 to 2%. That's my first one. 2 to 4. Can you see what I'm doing? I'm going in class in intervals of 2, 4 to 6, 6 to 8, and 8 to 10. Total of 20 observations. And then we go back to our original list and say, well, let's look at this original list. How many of these observations here fell between 0% and 2%? And you go through them all, and it was just the one. Okay, that's why my frequency here is just 1. Then we go to the next one. So, okay, now we're looking at between 2% to 4%. So let's go. That's 1 for 2%. That's another one that fits in between 2 and 4. That one fits in between 2 and 4. There's one between 2 and 4, and I think there's one more. So in total, 5 of my observations, and that's why that frequency is 5, etc., etc. Now what have I done? Well, I've taken all of my numbers and I've summarized them into frequencies, and it looks a little bit better, doesn't it? Because now what can I say? Wow, look at that. Okay, between 0 and 2, one of the observations. Now, what would you conclude? Most of the observations, okay, are falling between, well, at least 6 of them fall between 6 to 8%. Visually, it's a much easier way of looking at things. Okay, everyone comfortable with that? We move down to relative frequency. Relative frequency, okay. And again, just look at the words relative. I'm still dealing, everybody comfortable in the frequency, and there's my normal frequency, which we just showed you then on the previous page. Everybody comfortable with that? So no real difference over there. Okay, that's just a normal stock standard frequency calculation. Everyone comfortable with that? And there's my 20. That's exactly carbon copy of what was in the previous page. We're moving now from frequency to relative frequency. Relative just means really, okay, percentages. That's all. Okay, so, and as I say, guys, when you start to see these very fancy relative, in fact, that you guys today, in today's class, we will be handling, okay, relative frequency distributions. You say, my word, I wish I would never have come to that class. But look at the words, guys. Relative means percent. Frequency is how we're going to split them up. Okay, and distributions are just the numbers within the particular thing that I'm looking at. That's it. Okay, we look over here, guys, and we know the very first one was what? My class interval was 0 to 2%, no change there. How many observations there? Just the one. Relative frequency says, okay, just one. How many were there in total? 20. Is everyone comfortable? That's 5%. Let's look at the next one. Between 2 and 4%, frequency is 5. Okay, out of the total of 25 out of 20, 25%. And of course, what do we know, guys? That the total will equal 100%. Everybody comfortable? Over the page, okay, and just another nice little example for you over there. I'm not going to go through it with you, but just to show you a little bit over here. Okay, an analyst has gathered the following data, a whole batch of data for you. When I am constructing a frequency distribution using 5 intervals, and it just says to you, the first interval is between 70 and 90. And the question says to you, what is the 4th interval? And then what, the only thing that you really got to take out of this particular question, guys, is that if the intervals, the first interval is between 70 to 90, we know that there's a gap of 20 between them. So, and remember, what do we say about that? Each and every single time we have that, okay, is you've also got then to be able to keep that consistent throughout the period, okay, and make sure that it's 20 every time. So it'll go 70 to 90, then it'll go 90 to 110, see still a gap of 20, 110 to 130, etc., etc. Everyone comfortable with that? Okay. And by the way, that was just another example there for you. Look at this one. Cumulative relative frequency. Now imagine I told you today we're going to be doing cumulative relative frequency distributions. Wow, that's fancy. Not so. Okay, let's go again, guys. Simple. The only difference over here is in the relative frequency from before, when we moved from relative to cumulative relative, is, remember the first one. The first observation is 1 out of 20, 5%. Everyone comfortable? The second one was 5 out of 20, which is 25%. Now what I'm doing, guys, is what? Well, can you give that to me in a cumulative fashion? Sure. The first one was 5. This one is 25. 5 plus 25, 30. And you just accumulate them as you go. Of course, at the end, it'll still be equal to 100%. But my cumulative at the very end will also be 100% or 1. Nice and simple. Okay. Top of page 8, we're looking over here at what we call a contingency table. And a contingency table also sounds fancy, but it's just a table that displays the frequency distributions of 2 or more categorical variables simultaneously. Okay. And what are my categorical variables here? Well, my top line, my categoricals are large cap, mid cap, and small cap. Okay, and my categoricals going down the columns are financial sector, energy sector, healthcare sector, and IT sector. Okay, why is it called a contingency table? And this particular one would be called a 5 by 3. Why 5 by 3? Because there are 5 sectors by 3 different types of market caps. Everybody comfortable? And now we can say, we can look at everything. I said, do me a favor, can you tell me how many mid caps, how many companies there are in the financial sector? And what did you tell me? There's 175 companies in the financial sector. How many of those are large caps? 100. How many mid caps are there in RT? 125. Can you see how this contingency table works? And you can see everything so wonderfully. Okay, just some names and definitions for you guys. The date is also called joint frequencies. Okay, why joint frequencies? Joint because we're joining one variable from one row and another variable from that column, and we start to work with these specific items. Okay, the joint frequencies, okay, are added across rows and across columns. Okay, and the sum of these is what we call marginal frequencies. Okay, as mentioned before, we would say, what is the marginal frequency for financial stocks? That's just the total of 175 over there. Everybody comfortable? Okay. We'll see the more we move into deeper into data analysis, we make use of things like confusion matrices. Okay, that will help us evaluate a model. Okay, that's quite a bit deeper. And the test we use is called a chi-square test of independence. But again, guys, that's when we're going to go quite deep then into the quant section. And obviously that's not for what we need right now. Okay, we move down. This is a bit of an easier section, guys. Not that the last section was overly complicated, but now we're talking about visualizing. And in other words, when you, for example, have to present a report to a board of directors, you have to present a report to a group of analysts, whoever you're reporting to, it's often so much easier if your data is presented in a visually pleasing manner and makes it easy for people to see. And we're going to go through a whole batch of different visualizations. Let's start off with what we call a histogram and a frequency polygon. Look at the histogram. Now, we're going back to what we saw before, guys. Same old class interval example with the various frequencies, which we know summed to 20. A histogram can show you very quickly that if you look at it, oh, look at that one. That one is where most of the dividend yields sit between what, guys? As you can see, between 6 and 8%. and its frequency over there, you can see, corresponds to 6. So a histogram lets you see things very easily, very quickly. And again, over here, you would probably conclude as well, not much happening there between the 0 to 2% level of div yield. That makes sense. Okay. A frequency polygon is a similar concept. I'll show you the picture of the frequency polygon over here. What do you notice there between 0 to 2? Again, how many observations? Just the one. Between 2 and 4, there's my 5. Between 4 and 6, there's the 4. Between 6 and 8, that was the big one, there's your 6. And so you can see how it goes. You can see it goes up and down as, and one could almost conclude that it starts to go up more as your div yields start to, and seems to peak at between 8 and 10%. Okay. We've got ourselves a bar chart, and the bar chart, we're going to, for the bar chart, we're going to be working with our table that we dealt with before. There's your market cap. There's your 3 different levels. You've got a large cap, a mid cap, and a small cap. And on the column side, the sectors: financial, energy, healthcare, IT over there. Now look what we can do in terms of a bar chart. Now you can see it nice and easy. Which is the one that's got the most amount of companies? Energy. You can see that over there. And we can confirm that over there. There is your 475 companies. Which is the next biggest? Well, it looks like a dead heat between IT and healthcare. Okay. And the other ones, those are quite small. Insurance. But you can see how a bar chart shows you things very effectively. Okay, we can also make the bar chart a little bit more illustrative, which is now called, guys, a grouped bar chart. So for example, over here, healthcare, okay, we can see, yes, there's a lot of stuff happening, but most of the stuff happens in a blue section, which is large cap. Okay, so yes, healthcare is very busy, but not so much in the green section, the small cap section. That's called a grouped bar chart. Shows us things a little bit more illustrative, also called a clustered bar chart. Okay, we can then have a stacked bar chart. You probably think this is getting a bit crazy, and again, it just shows you things again. Again over here, you can see healthcare. The biggest section over there is its large caps. Okay, when I move across to energy, what would your conclusion be? Well, it seems to be fairly evenly distributed among large, mid, and small caps. That makes sense. Okay, we come across to the next one, a tree map. Okay, I'll go over the page over here to show you the tree map, and look at the tree map. The tree map will show you, for example, all the greens are your small caps. Most of the small caps sit, well, I suppose, between energy, RT, then, and healthcare. Looking at the large caps, and you can make all your various conclusions like that. That's called a tree map. A word cloud. What's a word cloud? A word cloud is really a way that we can, also sometimes called a tag cloud, and it's a visual representation for text. Okay, and you can see over here, when I put my word cloud together, it will show you which word comes up in the text the most. Obviously, that word is happiness. You can see how big that one comes up, followed by maybe fun, followed by joy, I suppose, safe, health. Those are the ones that seem. So the size of each word is almost representative of its frequency in the text. That's called a word cloud. A line chart. We've seen this a little bit before as well. It's a very similar concept. Okay, but a line chart is very often used when I'm making comparisons. If you look over here, okay, if I'm trying to compare year on year, so for example, I would have my 2017 year there in the green, okay, and you can compare that then month on month, okay, with the next year, okay, which is 2018. You can say, oh, the year started off a little bit lower. April kicked in nicely. We started to dip a little bit, okay, picked up nicely again October, and ended off the year a little bit higher than the previous year. Okay, it's a nice way of doing a comparison. We've also got a bubble line chart. I'm sure you guys are laughing at the moment. How many of these charts are there going to be? There we go. There's another bubble line chart where I use bubbles. Okay, also nice and easy to see and to represent the data. We move now to an interesting one called a scatter plot. A scatter plot goes by many different names: scatter graph, scattergram. Okay, and what this particular scatter plot does, guys, and it's an important one. Okay, this particular scatter plot allows you to, specifically when I work with bivariate data, remember the word, and guys, I'm begging for no complications in quants. Okay, let's just look at the words. Bi means two. Okay, two kinds of data, and we can kind of like compare the data, and I'm looking specifically, is there a relationship between these two variables? Okay, now let's have a look over here, page 14. And I've got hours that my candidates study for, and then the grades that they obtain. Okay, can you see that's bi? That's two sets of variables. Variable number one is hours, and variable number two of the grades that they obtain. Is everybody comfortable with that? Okay. What the scatter plot, scattergram, whatever you want to call it, does is it plots my data onto a bit of a graph, onto a plot. Now, if you look at that, well, if I had to draw a line which is called linear, and guys, this is what we're going to do when we get to the core section on quants. We get to, okay, what we call linear regression. Okay, linear is my line. Okay, and let's just try to draw a bit of a line over there. No, it's not an exact line. In other words, not all of the observations lie directly on the line, do they? No, but they're close. And what would I conclude just looking in that? I'd say, there is somewhat of a linear relationship going on. And when I could conclude such a thing, guys, that there is somewhat, not a perfect, but somewhat of a linear relationship, then what could I go back and tell my candidates? Listen, guys, the more hours you put in, yes, there's a relationship. The more hours, very likely, a good chance that the higher your grades will be. Okay, so there we've got our various scatter plots. Okay, and a scatter plot matrix. Okay, allows for an easy inspection when there's what we call pairwise relationships. And I can put them all into one combined visual. A heat map. Okay, a heat map is also kind of like a visual map, but it gives you its direction from the fact that certain things will go for different colors. For example, in the heat map, red may be, oh, that's a very dangerous, urgent color, needs to be sorted out straight away. And then you might well get green, which is a fantastic color, no problems there at all. Okay, and that's how that would work. Now, after all of that, how do you select among these various visualization tasks? Well, the board member says to you, do me a favor, please, can you present a bit of a presentation for us? But please, we're not such numbers people. We want to see this visually. Now, the big question is, well, which one are you going to pick? Okay, let's have a look over here. Now, it's all going to depend. If we're trying to depict a relationship between variables, use a scatter plot matrix, or a heat map. Okay, if it's a distribution, okay, and it's a numerical distribution, well, use a histogram, frequency polygon, or a cumulative distribution chart. For categorical data, remember, categorical data is more qualitative data, not so much quantitative. A bar chart, tree map, or heat map. And if it's unstructured, remember, we can use that lovely word cloud which showed us which words came up the most. If I'm looking for a comparison, okay, among the various visualizations, we can use bar chart, tree map, heat map. And if I'm looking to do that over a time period, I'll use a line chart, or even I could use a bubble line chart over there. Okay, that brings us to a nice point over here, guys, and I think we will close off the first video over here because this ends off at a nice closing point, and we will continue onwards then with measures of central tendency that's coming up now in video number 2.